Assalamu alaikum students. Can you see the slide? Am I audible to you all? Is my voice is clear? I hope you all can see the slides. Can anyone please confirm? Are you able to see the slide? Yeah, thank you. Okay, so this is the continuation to our previous session. I hope you all remember in the previous lecture, we learned about what is a buffer overflow, how the attackers exploit the buffer overflow vulnerabilities, and also we learned about the history of major buffer overflow attacks, all these things. So now a very important question will rise like, why are some programming language vulnerable to this buffer overflow attack, and while some other programming languages are not. So the answer will be depending on how the programming language manage the computer memory. How the programming language manage the computer memory is very important. See, we need to understand how the programming languages are evolved and how memory is managed at different programming levels, and why some languages are more vulnerable to the buffer overflow attack than the other programming languages. See, many modern high-level languages automatically check the memory boundaries. If a program attempts to write beyond an allocated buffer, the runtime detects the error, the operation will be stopped, the memory corruption will be prevented. So this makes classic buffer overflow attacks much more difficult. So the overhead, as it is mentioned here, the overhead, which means it is an additional processing which required to provide the safety features like automatic memory checking, garbage collection, runtime type checking. So these features will improve the security, but it may slightly reduce the performance. It may reduce slightly the performance. And see, for example, let us say in our university, you may learn the programming languages like C++, Java, and even Python and all. So as a student, you learned that C++ programming language, where this language will allow direct memory access, and therefore it requires a very careful input validation to avoid the buffer overflow. But when you learn Java programming language, the runtime in Java programming language automatically check the array boundaries. It will help to prevent the classic buffer overflow attack. So when you compare these two programming languages, you would have understand the trade-off between their performance, flexibility, and also a safety. So remember, the machine level, which means the CPU processes data stored in registry and memory, whereas the assembly language, it is the programmers manually manage the memory and data interpretation. The high level languages are going to provide strong type checking and safer programming features. So then we have runtime safety also. Runtime safety, like many modern languages, automatically detect the memory boundary violations. Whereas if you talk about C or C++, it offer direct memory access and high performance, but it require careful memory management. And then we have the legacy code. See, the older software often written in C, C++, and it may still contain buffer overflow vulnerabilities if it is not properly maintained. And then we have the concept of function call and the stack frames. See, when we want to understand how the stack-based buffer overflow attacks the work, we first understand what happens if a function is going to be called, what is the stack frame, and why are the return addresses and local variables are stored on the stack. Because, see, we all know that a function is a reusable block of code that perform a specific task and it can be called from different parts of a program. Like, for example, calculating the salary, finding the student marks, login verification, display port, like this. So, a function call, which means the one function which requires another function to execute. To execute. So, a stack is a memory structure that follow last in first out principle. So the last function is called, which is the first function to return. Since the function a stack frame is a block of memory created on the stack for each function call. So the calling function will need the data structure to store the return address and also the parameters to be passed. So for that, we have a return address, which is the memory location where the program should continue after the called function finishes the execution. So here, the thing is that every time a function is called, the operating system will create a stack frame, as you are seeing in the image. To store the return address, function parameters, and local variables, each function call will receive its own independent stack frame that will be allowing multiple functions to execute correctly. So because important information such as the return address is stored within the stack frame, the stack-based buffer overflow attacks the attempts to overwrite this data. So potentially it will be allowing the attackers to al- alter the normal execution of your program. So that is why every function call creates its own stack frame to store the parameters. So the local variables and the return address, and this organization of stack will enable the correct program execution, but also it make the stack a critical target for buffer overflow attacks, and it emphasizes the importance of secure memory management and input validation. And then the stack buffer overflow. See, a stack buffer overflow is like the one which happens with a fixed size buffer that is stored in stack memory, like as you can see in this picture. It receives more data than it can hold, so it will be causing nearby stack data to be overwritten. So as we all know, one of the earliest internet worms, the Morris worm, the 1988, it is used a stack buffer overflow vulnerability in the fingered service to spread across the Unix computers. So this attack demonstrated that a programming error is in stack memory that could allow remote code execution and all. And also, if you remember in the previous slides, we learned in 1996, Alpha 1, that is a published article smashing the stack for fun and profit. So the article is clearly explained about the stack memory, stack frame, return address, buffer overflow explanation, all these things. So it becomes one of the most influential article in the software security purpose. See, the main thing here is a stack buffer overflow happens when a local buffer stored in a function stack frame which receives more data than it can hold, because the stack also store important control information like a saved frame pointer and return address. So an overflow can override these values and redirect the program execution. So historically, the attacks like the Morris swarm and the techniques are going to described in smashing the stack for the fun and profit. They demonstrated the seriousness of this vulnerability. So most of the modern systems, they reduce the risk through the compiler and operating system protections, but the secure programming and proper input validation will remain the most effective defense mechanisms. And then we have the concept of shell code. Let me show you the example. Yeah. See, the shell code is the malicious machine code that attackers try to attempt to execute after successful exploiting a buffer overflow vulnerability. So the shell code is like a simple and small piece of machine code that is supplied by an attacker, and it is executed after successfully exploiting a software vulnerability like buffer overflow. See, the shell code will contain the instructions that perform the attacker's intended action. See, the important thing is that in early computer systems, successful exploitation often caused the vulnerable program to start a command line shell. So a shell will allow a user to execute operating system commands. Okay, so here the thing is that in a classic stack buffer overflow attack, the attacker will send oversized input. The input will contain shellcode. The shellcode is stored inside the vulnerable buffer. The return address is overwritten and the CPU jumps to the shellcode. The important thing is that while early shellcode development required a very deep assembly language expertise, but nowadays modern security frameworks are helping the authorized professionals to study the vulnerabilities, perform penetration testing, and improve the defensive security so that the modern protections such as like DEP, ASLR, and secure coding practices significantly reduce the effectiveness of classic shell code based attacks. And then stack overflow variants. See, a stack overflow variant is like a different target, or you can say the object. It is like an objective or that an attacker may pursue after successfully exploiting a stack buffer overflow vulnerability. So even the attack method may be similar. The target system or the attacker's objective can be different. So a system utility is going to be a program that help to manage or maintain the operating system. So the file management tool, backup utilities, compression utilities, administrative tools. See, these programs are trusted because they are supplied with the operating system. So importantly, if you see here, like for example, in our university, we are operating several branches, right? Like Jazan branch, Aba branch, Jeddah branch, Real. So, and in each campus, various services are running, like including a web server, library management software, or even the student portal. So, the IT security team, they perform a regular vulnerability assessment on these networks over the branches and services, and also the shared software libraries. So, they will apply the security updates promptly, and they will use the application sandboxing to limit the impact of any potential vulnerability. So with all this, Stack Overflow attacks can target many types of software and purpose different objectives and pursue different objectives. But modern layered security, including secure coding, application isolation, memory protection mechanism, and continuous monitoring. So these all will help the organizations to defend against these historical attack techniques while maintaining reliable and secure system. And then the buffer overflow defense. See, the thing is that buffer overflow vulnerabilities have been one of the most common software security problem for many years. So the attackers, they try to continue to exploit them because they may they may allow unauthorized access, or they can crash the application, or they may enable the execution of malicious code, or they affect many different types of software. So even today, the developers continue to discover the buffer overflow vulnerabilities in the software. So very importantly, if you talk about the compile time defense, the main purpose of this one is to improve the software security before the deployment, like secure coding, compiler warnings, preparing the stack canaries, safer library functions, and then static code analysis like this. And there is another approach, that is runtime defense. In this one, it will detect or mitigate the attack while the program is executing, like for example the ASLR mechanism, DEP, runtime stack protection, these types of. So what I want to say is the buffer overflow vulnerabilities continue to exist because of the legacy softwares, memory unsafe programming languages, and the programming errors. Even though their causes and defenses are well understood, the organizations therefore rely on two complementary defense approaches. What are that? Compile time and runtime. Okay, so then we have the, let us see more in detail about the compile time defense. See, the compile time defenses are the security mechanisms. They are the security mechanisms and the programming practices that detect or that prevent the buffer overflow vulnerabilities while the software is being developed and compiled before it is going to be deployed. So instead of stopping an attack after it happens, the compile time defense aim to prevent the vulnerabilities from being introduced into the software. See, here one important thing is that programming languages and also the safe code safe code technique that we use. See, for example, in our university, we are developing a new online learning management system. So the development team choose the modern programming language with strong typing for most modules and use secure coding practices for the remaining C++ components. So every new feature will undergo peer review and security testing before deployment. So the application also validated user input and handle the errors gracefully to reduce the risk of buffer overflow vulnerabilities and all. So the important thing is that the compile time defense will protect the software before it is deployed by combining modern programming languages, strong typing, range checking, safe coding techniques, and through the code reviews. While some applications still require modern memory unsafe languages like C, C++, for the performance or hardware access, so the developers must follow secure coding practice while writing the code. They have to design the software securely from the beginning and ensure that application fail gracefully when the error happens. So this practices significantly reduce the likelihood of buffer overflow vulnerabilities and all. And then language extensions, safe libraries, and the stack protection and all. See, all these techniques which comes under the compile time defense, which helps or applied before the software is going to be executed. So it will be making the program safer. It will be making the program safer. So a language extension is an additional feature that is added to a programming language to improve the software safety without completely replacing the language. So instead of creating a new programming language, the developers improve the existing language like C, C++, and all. And a safe library is a collection of replacement functions which are designed to perform the same task as standard C library, but with some additional security check and all. So instead of replacing the entire programming language, The developers replace unsafe functions with the safer alternatives. And then we have the stack protection. See, the stack protection is a mechanism where the compiler generated security mechanisms that help to detect the stack corruption before before a function is going to be returned here. So the compiler automatically insert the extra checking code into the program. Okay. So in overall, I can say that the compile time defense is going to strengthen the software before deployment by extending the programming languages with additional safety features and replacing unsafe library functions with safe libraries and using the compiler based stack protection mechanisms. The techniques like stack guard, uh, WinGS, GCC stack protection, stack canaries, and protected return addresses. So this all will help to detect the memory corruption before it can be exploited. Although these mechanisms may introduce a small performance overhead, so they significantly improve the software security and reduce the likelihood of successful buffer overflow attacks and all. And then very important thing, that is runtime defense mechanisms. See, the runtime defenses are the security mechanisms that are going to protect a program while it is running by detecting or preventing the exception of vulnerabilities exception of vulnerabilities. Unlike the previous one, the compile time defense, they do not remove the programming error. Instead, they make it much harder for the attackers to exploit the vulnerability successfully. So here the thing is that we have the runtime defense like non-executable address space, so which is going to prevent the execution of code that is stored in data memory like stack or heap. Then virtual memory protection, which is like assigning the read, write, and execute permissions to different memory regions. MMU support, so the hardware enforces memory access permissions. The address space randomization, so it is going to randomize the memory address each time for a process starts, and randomize the libraries, which makes the locations of shared libraries and standard functions unpredictable. Then overall benefit, which makes successful exploitation of buffer overflow vulnerabilities and significantly more difficult also. So with all this, if you see the techniques such as like non-executed address space NX or DEP and address space layout randomization, ASLR, do not remove the buffer overflow vulnerabilities, but they significantly reduce the likelihood that the attackers can successfully exploit them. And then the guard pages. See, a guard page. A guard page is a protected memory page placed between important memory regions. So if a program attempt to access this protected page illegally, the operating system immediately detect the violation and terminate the program. So when we think of the guard page as a security fence that is placed between two valuable areas, so we need to make sure that the program is going to use several important memory regions like stack, heap, global data, program code. So if a buffer grows beyond its allocated space, it may overwrite another memory region. So a guard page will create a protected separation between these regions and all. So a stack frame is the memory allocated for one function call. Normally, the stack frame are placed one after another. Some security mechanisms insert protected pages between the important stack region to detect the abnormal memory growth and all. See, the thing is here, The God pages are a runtime defense mechanism. So that means it is protecting the programs by placing inaccessible memory pages between the critical memory region like stack, heap, or stack frames. So the memory management unit is going to mark these pages as protected. If a program attempt to access a God page because a buffer overflow or other memory um, error, the operating system immediately terminate the process, which will be preventing the future memory corruption, even though the God pages required additional memory, and it is going to introduce a small performance overhead that they provide an effective layer of protection when combined with NX or DEP and ASLR and all. So then the other overflow attacks are there. See, an overflow attack is going to happen when a program write more data than a memory location or a variable that can safely hold. So even though the stack overflow attacks are common, the attackers can also target the heap memory, global data, format strings, and the integer calculations. So each type of effect is going to different part of the program, different part of the program. See, besides the stack overflow, there are various important variants like stack overflow, heap overflow, global data overflow, format string overflow, integer overflow. So each one of they have their own specific task. Like if you talk about the stack overflow, if we discuss about the stack overflow, it happens when the excessive data override the memory allowed on the program stack. At the same time, when you look at the heap overflow, the heap is an area of the memory that is used for dynamic memory allocation. So the memory is allocated while the program is running. So a heap overflow is going to happen when a program write beyond the allocated heap memory block. So instead of affecting the stack, it corrupt the nearby heap memory. So here the global data consists of the variables that declared outside the function. So these variables will remain available through the entire execution of the program through the entire execution of the program. Okay, so then the format string overflow. See, a format string will control how the data is displayed or processed. Like for example, when printing output, the developers specify how values should be formatted. So if a program improperly treat the user's supplied input as a format string, the unexpected memory access or modification will be happen. So this is known as the format string vulnerability and all. So in overall, the buffer overflow attack are not limited to the stack alone. So the programs may also experience the heap overflow, global data overflow, format string vulnerabilities, and the integer overflow. So each affecting different aspects of memory or the program execution while the operating system is protecting and the God page concept will reduce the likelihood of successful exploitation. So that is why the most effective defense is secure software development. So carefully design, input the validation, boundary checking, safe memory management, and through the code reviews, we can help to prevent these vulnerabilities before the software is deployed. Okay, a replacement stack frame, which is a historical stack overflow technique in which an attacker attempt to replace or to manipulate the function's stack frame so that later program execution follow an attacker control path instead of the original one. So there are various limitations it is having. Why? Because it requires precise knowledge of memory layout, and small corruption may not be sufficient. Then invalid replacement frame often cause some program crash, or modern memory protection mechanisms greatly reduce its effectiveness. Like this. See, in overall, the replacement stack frame is an important historical example of how even the limited memory corruption, such as an off by one error, can influence the program execution. So, studying this type of techniques reinforce the importance of secure coding, careful boundary checking, and the modern memory protection mechanisms in building the resilient software systems and all. So then we have a return to system call mechanism. So a return to system call, which is a attack that is a historical buffer overflow technique in which the attacker redirect the program execution to an existing trusted library function instead of executing newly injected code. So instead of placing new machine code into memory, the attacker attempt to reuse the code that already exist in the program library and all. So instead of executing newly injected code, the program follows a different path through already existing executable code and all. See, the thing is that the researchers later demonstrated that multiple existing library functions could be linked together during the execution. So this general idea has evolved into more advanced techniques studied in computer security research. So the thing is that any stack protection mechanism to detect the modification to the stack frame, or it will return the address. That means the compiler protection such as like the stack canaries, stack guard, GCC stack protection. So they check whether the stack frame return address have been modified or not. So if the corruption is detected, the program is terminated before it is going to be returned. So that is why a return to system call, which is an attack that is a historical Stack Overflow technique that redirect the program execution to the existing executable library function. So instead of running newly injected machine code, it was developed as a response to the non-executable stack protection. So the modern systems they defend against this technique by using the stack canaries, address space layout randomization, guard pages, control flow integrity, and in overall, it is going to secure the software development practices, making successful exploitation much more difficult and all. Most of the modern operating systems they rely on the defense in depth rather than a single security mechanism. And then the overflow heap overflow. See, the heap, what is the heap? It is a region of memory that is used by a program to store dynamically allocated data during the execution. So unlike the stack, whose memory is automatically managed during the function call. The heap memory is requested and released by the program as it is required. So a heap overflow will happen when a program write more data into the heap allocated buffer than it was designed to hold. So the extra data may override the adjacent heap memory and all. See, the thing is that unlike the stack, the heap does not contain a function return address. So therefore, a heap overflow does not directly override a return address. So in the way a classic stack overflow that might. So this is an important difference between the stack and heap overflow. So please remember, a heap overflow happens when a program writes beyond the boundary of a heap allocated buffer, potentially corrupting the nearby dynamically allocated data or heap management information. So the modern operating systems will reduce the risk of exploitation by making the um, by making the heap overflow, which does not directly override the functions or return address. And also, see, the modern operating systems, they reduce the risk of exploitation by making the heap non-executable and randomizing the heap memory locations, while secure coding and proper boundary checking will remain the most effective um, long-term defenses and all. And then we have the global data overflow. Global data overflow. See, the global data is a memory region that store the global and static variables which remain available throughout the entire execution of a program. So unlike the local variables, the global variables are declared outside the function, which exists until the program is going to terminate, and it can be accessed by multiple functions. So a global data overflow happens when a program write beyond the boundary of a buffer stored in the global data region, overwriting nearby global variables or other important data and all. So the aim of the overflow, if you see here, historically, the security researchers demonstrated that if an important function pointer becomes corrupted, then when the application later attempted to use that pointer, the program's control flow could be affected. So the thing is that here the global data overflow is going to happen when a program writes beyond the boundary of a buffer that is stored in the global data region. So potentially corrupting nearby global variables or other important program data. So unlike the stack overflow, this attack is going to target the memory that remains available for the lifetime of the application. So that is why the modern operating systems reducing the risk by using DEP and NX to prevent the execution of code from the global data region, and to randomize the memory locations, and also to detect the illegal memory access and improve the software design that separate sensitive control information from the writable buffers and all. And then the software security. See, the software security is the practice of designing, developing, testing, and maintaining the software so that it is resistant, so that it is resist the attacks and protect the data, even systems and even the users from the security threat and all. So in simple, I can say the software security is built into the software from the beginning. From the beginning. So most of the software attacks do not happen because of the computer survey. Instead, they happen because uh, the software contains mistakes made during the development, common programming mistakes, which include missing input validation, incorrect boundary checking, unsafe memory handling, poor authentication, improper error handling. So these mistakes will create the software vulnerabilities and all, software vulnerabilities and all. See, the thing is that input validation, which means checking whether the user input is correct, safe, and within expected limit before it is processed. So without proper validation, the unexpected and malicious input may cause the security problems also. And then the cross-site scripting, which is a web application vulnerability in which the web-based applications improperly handle the user's supplied data or content that will allow the unintended script code to be delivered to the user browser and all. So in overall, if you see, according to the NIS TIR 8151, this is a document, and here the organizations can reduce the software vulnerabilities by preventing them through secure design, coding, detecting them through effective testing, and reducing their impact through resilient software architecture and all. So most of the modern cybersecurity, which begins long before the software is deployed, and then the software quality is the degree to which the software performs as it is intended, with the functions correctly and reliably and effectively, which undergo normal operating conditions and all. So the software quality mainly focus on making the software reliable, correct, stable, and easy to maintain. But whereas software security, if you see, it is the ability of software to resist intentional attacks and continue to protect the data, systems, and even the users when even when the malicious inputs are provided. So the software security assumes that someone may deliberately try to misuse the program. So with all this, the software most of the modern organizations, they recognize the quality alone is not going to be enough. An application may rarely crash and still contain the vulnerabilities that the attackers can exploit using carefully crafted inputs. So that is why the development team increasingly integrate the quality assurance with the secure software development lifecycle. So by combining the structured design, functional testing, secure coding, code reviews, input validation, and the specialized security testing, the organizations can deliver the software that is both dependable, resilient, and against the evolving of cyber threats and all. So then we have defensive programming. Defensive programming. See, the defensive programming is a software development approach in which the programmers write the code that anticipate the errors, validate the assumptions, handle the unexpected situations safely, and we continue to operate securely whenever it is possible. It also known as secure programming because many secure coding practices come from defensive programming principles and all. See, the formal definition is very clear here. It is a form of defensive design to ensure that continue the function of software despite unforeseen usage and all. So an abstract program model is a conceptual way of viewing how the software should process the information securely rather than focusing on specific programming languages. So it emphasizes the sequence of a safe operation that every program should follow. So like the defensive programming, or you can call it as secure programming. This is a software development approach which anticipate the errors, it validate all the inputs and assumptions and safely handle the unexpected situations so that the software can continue operating reliably. It requires the developers to consider every aspect of program execution, the operating environment, and the data being processed. So by following the principles like assuming nothing, checking everything, and applying Murphy's law during software design, the developers can significantly improve both the reliability and security of their application and all. And then security by design. See, the security by design is a software engineering approach in which the security is planned, designed, implemented, tested, and also maintained throughout the entire software development lifecycle instead of being added after the development. So, build the security into the software, not onto the software. That is why in almost every engineering field, safety, reliability, and security, these are considered from the beginning of the design process. Either it is a civil engineering, mechanical engineering, aerospace engineering, even computer engineering also. So the engineers, they do not build a system first and then decide whether it is going to be safe or not. They design for safety from the scratch itself. So the same way software engineers also follow the same principle. So most of the leading software organizations now, they follow security by design as a core engineering practice. The security is no longer viewed as an optional feature or final testing activity. It is treated as a fundamental quality attribute alongside the functionality and reliability. So by embedding the security into requirements, architecture, coding standards, testing, deployment, and maintenance, so the development teams will reduce the vulnerabilities, which lowering the long-term cost and building the software that the user can trust. And then handling the program input. See, first understand what is the program input. So the program input is any data that enter a software application from an external source, and it is going to be processed by the program. So the program should never automatically trust this data. Then the program should never automatically trust it. So one of the most common causes of software vulnerabilities is incorrect handling of input. Incorrect handling of input. So a program can receive data from many different external sources. Okay, before securing the software, the developers must first identify where the data is coming from, who provided the data, whether the data can be trusted or not. So that means every input source should be documented during the software design process. And also, a common programming mistake is assuming that users will never enter more data than expected. Like, for example, a program creates a buffer capable of storing 512 bytes. So the developer assumed that no user will enter more than 512 bytes. If this assumption is incorrect and the program does not verify the input length before storing it, the extra data can exceed the buffer capacity. So that is why many of the most serious software vulnerabilities happening from improper input handling rather than the complex programming errors. So the modern secure development practices require the developers to identify every external input source. So we need to validate all the assumptions about incoming data and process only trusted. So well-formed input when combined with secure coding standards and compromise the security testing, proper input handling forms one of the strongest defenses against the common software attacks and all. And then the interpretation of input. See, when you look at the interpretation of input mechanism, it is the process of understanding the meaning, the format, the type, and encoding of input data before it is going to be proceeded with the program. So the computer must know exactly what the input represent before using it. For example, imagine you are receiving this value 1, 2, 3, 4, 5. So what does it mean? It could be a student ID, it could be a faculty ID, it could be a bank account number, it could be a zip code. So without proper interpretation, the software may process the data incorrectly, right? So the software generally process two major categories of input. One is binary input and another one is text input, binary input and text input. Like for example, if you are trying to get an admission in SEU for master's program and the university admission portal accepts the student name in English and Arabic, you uploaded the PDF transcripts and profile photograph. So before processing each submission, the application identifies whether the input is text or binary. So it is going to verify the character encoding for names, and it is going to check that uploaded files are valid PDFs or images and reject the incorrectly formatted input. So that means this improves both reliability and the security, reliability and the security. In the same way, the modern applications, they process the data from many different sources and in many different formats. So the secure software development, which always requires the developers to correctly interpret the input, to correctly interpret the input before processing it, ensuring that text uses the appropriate character encoding and the binary data that follow expected formats. So combined with input validation, this approach will reduce the likelihood of software errors and the vulnerabilities, while it enable the reliable support for the international users and diverse data types and all. And then a very important topic, that is injection attacks. See, the injection attack is a security vulnerability in which the untrusted input is interpreted as part of a command or the instruction. So this will allow the input to influence the program execution. That means the program mistakenly treat the user input as executable instruction instead of the ordinary data, instead of the ordinary data. So that is why an injection attack is a software vulnerability which happens when improperly handled input that influences the execution of a program. So these vulnerabilities, they often arise when applications pass the user supplied data to helper programs, utilities, databases, or even other software components without proper validation. So the injection vulnerabilities have been common in scripting environments and web applications because they frequently process the external input. So the best defense is to treat all the external input as untrusted, validate it carefully, and ensure it is processed strictly as the data rather than executable instructions and all. So then you can see here there are two things. One is SQL injection and code injection, two different types. See, these two vulnerabilities are happening when the application failed to properly validate the user input before passing it to the database or to the application code. So if you look at the SQL injection, it is a vulnerability that occurs when untrusted user input is incorporated into a database query without proper validation or secure query construction. So it will allow the input to alter the intended database operation. So it is one of the most well-known web application vulnerabilities. Then we have this code injection. So the code injection is also a vulnerability in which an application incorrectly treat the user supplied input as executable program code instead of ordinary data. So the application unintentionally executes the instruction that should never have been accepted as the code. So that is why the professional developers, they address these risks by combining secure input validation, parameterized database queries, secure coding standards, and the regular security testing throughout the secure software development lifecycle. Okay, Fatima, no problem. Now we have another important concept, that is cross-site scripting attack. Let me show you the diagram. Yeah. See the cross-site scripting XSS, which is a web application vulnerability in which untrusted input supplied by one user, which is included in a web page viewed by another user. So this will be causing the browser to execute unintended client-side script, unintended client-side script. Okay. So many web applications will allow the user to submit the content like comments, reviews, messages, form posts, and profile information. So if this content is displayed to other users without proper validation and output encoding, the browser may treat the part of it as a executable client-side code instead of ordinary text. Like for example, in the discussion forum in the university website, so they allowed students to post the question and comments. Before displaying student submissions, the application validate the input and safe encodes it for the HTML output. As a result, every student browser display the content as ordinary text rather than interpreting it like an executable script. The same like for example, if you take a bank, they have online customer support portal which allow the customer to submit the feedback. So before the feedback is displayed to the bank staff or other authorized users, the application validates the content and encode it for the safe display. So this helps to ensure that the customer message cannot alter how the web page is going to behave. So the thing is that the cross-site scripting will remain one of the most common web application vulnerability, because the modern websites frequently they display the user generated content. So the professional software engineers they reduce this risk by combining, they have secure input validation, then context. So now, okay, so the cross-site scripting will remind us that every piece of user-generated content should be treated as untrusted. So by validating the input, encoding the output, and following secure web application practices, the developers can ensure that browsers display the user content safely rather than interpreting it like a executable script. And then we have validating input syntax. See, the input syntax validation is the process of checking whether the user input follow the expected format before it is accepted and processed by the application. That means the application will check whether the input looks correct before using it. So to ensure the input data that meets the assumptions, it is very much required. Why? Because, see, for example, as you all know, the university admission portal, for example, they require student ID to contain exactly 10 digits and email address to be followed with the university standard format. So before accepting an application, the system validate each field to the expected syntax. Even like when you create a Gmail or something, they will validate whether you have given in a proper format or not, like this. So the applications containing incorrectly formatted information are rejected with clear error message. So the student can correct with the inputs, right? That is what we are doing here. The input syntax validation will ensure that external input matches the application's expected format before it is processed. So validating input syntax will ensure that the software accepts only the correct formatting that data, by defining what is allowed using the regular expression where appropriate, and rejecting invalid input early. And the developers can significantly improve both the software reliability and the security. Then alternate encoding. See, the alternative encodings are different ways of representing the same data or character while preserving its meaning. So the same character or text can sometimes be written in more than one valid encoding. See, that means a computer can store the information as numbers. So the same character or text may be represented using different encoding schemes like ASCII, Unicode, UTF-8, UTF-16. Even though the representation differs, they may still represent the same character or the same text. Like I said, while you are registering for masters in the student portal, you may give the name in English and Arabic, and also you will upload documents and URLs for online portfolios. So before validating the input, the application convert the text into a standard internal representation so that the equivalent character encodings are handled consistently. So this will ensure that validation rules behave the same for all students regardless of the language or encodings that are going to be used. Then validating the numeric input. So the numeric input is any input that represent a numerical value, and it is going to be processed mathematically by a program. Like either it may be a student ID, it may be a age, salary, marks, anything, but it is a number. So many software applications process the numbers, like in a university portal we will have student ID, marks, like this and all. So the computer stores the number using a fixed number of bits, a fixed size storage, which means the computer reserves a predetermined amount of memory for each numeric value. For example, there will be small numbers require less memory. There may be a large number which require more memory. So the size chosen determines the range of values that can be stored. So, validating numeric input is an essential part of secure programming because it must be interpreted correctly before they are processed. So, the application should verify that input is numeric, convert it successfully, validate its range, and handled signed and unsigned values consistently. Since the computer store the numbers using fixed size data types, incorrect interpretation or inconsistent comparisons can lead to the logic errors, and it may contribute to security vulnerabilities that include the weaknesses in memory related safety checks and all. So then secure software will treat the numeric input with the same care as text input. So by validating the data types, ranges, signs, and the conversion before processing, the developers will build the applications that are both reliable and resistant to the input related vulnerabilities and all. Then we have the input fuzzing. See, input fuzzing is a software testing technique in which a program is automatically tested using a large number of randomly generated or unexpected inputs to determine whether it behaves safely and correctly. So instead of manually entering a few test cases, the computer automatically try thousands or even millions of different inputs to see whether the program fail or success. So that is why the input fuzzing challenges the software with thousands of unexpected inputs, and also it is helping the developers to discover the hidden bugs and security weaknesses before the users or the attackers even encounter them. And then safe programming and correctly implementing algorithm. See, the safe program is the practice of writing the software that correctly process the data, safely handle the error, properly manage the memory and resources, and follow the secure coding principles throughout the development. So safe programming means writing the code that works correctly and securely under both normal and unexpected conditions and all. So then we have the correctly implementing algorithms. See, that means a good algorithm must be implemented correctly. If the developers misunderstand the algorithm or they introduce the programming mistakes, then what will happen? The software may produce incorrect result. It may become unreliable, and it may introduce the security vulnerabilities. So the compiler or runtime system translate the program into machine instructions, whereas the developer must ensure that the original program correctly written the intended algorithm so that the generated instructions are going to perform the expected operations and all. So in overall, please understand that the strongest security algorithms are effective only when they are implemented correctly. So safe programming combine careful design, accurate implementation through testing, thorough testing, and disciplined software engineering to build the application that are both reliable and secure. So then we have correct machine language and data interpretation. So the correct machine language means we need to ensure that the machine instructions are executed by the processor accurately, which represent the original high language program that is written by the developer. So the computer should execute exactly what the program is intended for. And also, the thing is that the correct data interpretation. See, the correct data interpretation in the sense we need to ensure that the data stored inside the computer is interpreted and used correctly according to the intended type and meaning. So the data, for example, inside a computer, all information is stored as bits 0 and 1, bytes 8 bits, right? So the computer itself does not inherently know whether those bits represent a number, a letter, or an image, or a date. So that means the meaning depends on how the program interprets them. How the program interprets them. So that means like secure software begins with writing the correct source code, but it achieves readability only when the code is translated faithfully into the machine instructions and the underlying data is interpreted consistently and also safely throughout the execution. And then the correct use of memory. See, sometimes a program does not know in advance how much memory it will need. For example, like number of students uploading the assignment or number of products in an online shopping cart, size of an upload document. So instead of reserving a fixed amount of memory, the program requires memory during the execution. So this is called the dynamic memory allocation. This is what we call it as the dynamic memory allocation. So the dynamic memory allocation is the process of requesting the memory from the operating system while the program is running. Unlike the fixed memory size, the dynamic memory will grow or shrink according to the program requirements and all. So that is why the correct memory management will ensure the application allocate the memory only when needed and replace it after the use. So preventing the problems like memory leaks and improving the resource utilization, the modern programming languages often provide automatic memory management, but the developers still need to understand these concepts because in concurrent application, multiple threads of processors may access the shared memory and also making synchronization essential to prevent the race conditions and maintain the consistent data. So, however, the synchronization must be designed carefully because improper use can lead to the deadlocks where the thread wait indefinitely for each other, and then interaction with OS and use of the variables. See, a program which communicates with the operating system to use the system resources like memory, files, hardware devices, and even the user permissions, that we call it as interaction with the operating system. So that means the operating system is going to act as a manager which is providing the services and also the resources for every running program. So when a program starts, it does not run directly on the computer hardware. Instead, the operating system will control the program execution, memory allocation, file access, device access, process scheduling, many things. So the application requests all these services from the operating system. So the applications always execute under the control of the operating system, which provide access to the memory, files, devices, permissions, and the other system resources. So before the program starts, the operating system also create an execution environment which contains the program arguments and the environment variables like path, IFS, and LD library path. So because these values originate outside the application, they should be treated as untrusted input and validate before use. So the programs, especially uh, those running with the elevated privileges, should minimize the dependencies on the environment variables. So it will verify the permissions when accessing the shared resources and follow the secure programming practice to ensure the reliable and secure operation and all. And then the vulnerable compiled program and use of least privilege. See, a vulnerable compiled program is a compiled application whose behavior can be improperly influenced because it relies on unsafe operating system settings or insecure execution environments. That means a compiled program may become insecure if it trusts external operating system settings without proper protection. And also, on other hand, we have use of least privilege mechanism. So the principle of least privilege is a user or the program should receive only the minimum permission necessary to perform its required task and no more. So that means give only the permission that are actually required. So in overall, a secure application not only execute the trusted code, but it also run with only the permission it truly requires. So by controlling the execution environment and following the principle of least privilege, the developers greatly reduce the opportunities for the attackers, and it is going to limit the damage if a vulnerability is exploited. And then root or admin program and a system call or standard library functions and all. See, the thing is that a root or admin program is a program that run with administrator privileges, and it is going to have the permission to perform highly privileged system operations and all. That means this type of programs will have the highest level of authority on the computer. So the program which is running with root or administrator privilege, they are attractive targets because they have extensive access to the operating system resources. Secure applications should use elevated privileges only when necessary, divide the privilege functionality into small modules, and continue the execution with normal user permissions. So whenever possible. So the applications are going to communicate with the operating system through the system calls and standard library functions, which may not always behave exactly as a programmer, and it is expected due to the resource availability or operating system optimizations. So therefore, the developer should always check the written values, handle the errors, and avoid relying on undocumented assumptions about operating system behavior and all. And then we have the race conditions. See, two or more programs or threads or processes, they access the same shared resource simultaneously without proper coordination, leading to the incorrect or unpredictable results. That means when multiple programs try to use the same resource at the same time, it will create the conflicts. It will create the conflicts. So the race conditions can happen whenever multiple programs or processes access the shared resources like mailbox files or CGI data files. So without proper synchronization, the techniques like file locking, locking files, and operating systems locking mechanisms. So these will help to coordinate, access, and maintain the data consistently, even though their implementation differs across the operating systems. Many applications also rely on the temporary files, which should be created using unpredictable names, protected with appropriate file permissions, and deleted after the usage. So following these practices, it will help the build software that is more reliable and resistant to the secure vulnerabilities and all. And finally, we have other program interactions. See, a program which communicates with other with or the uses the service providers by another program to complete the task. That means there is a program which often work together instead of working independently. So the professional software engineers, they understand that security extends beyond the program input. Every interaction with another application should be treated as potential unreliable unit until it is verified. And every program output should be generated with the correct format, with the correct encoding, and the destination in keeping in mind. So by validating the communications, the programs will protect the transmitted data, handling the exceptions, and it is going to produce the well formatted output. So the developers build the application that are both secure and intraoperable. So with this, we completed this module. In the next session, we will start with a new module. So students, please complete the task, that is a discussion board 2 activity is available on the blackboard. So please make sure that you complete the activity without fail. Okay. And also next week you all will receive uh, another assignment. That will be your last assignment. Okay. So if you have any queries, please feel free to ask, or else if you want to leave, yes, you are free to leave, and you can check your attendance on the system tomorrow.